Hello and welcome. In this tutorial, we will implement a fluid image distortion in Max. So this video is building on two previous tutorials of mine. The first one is the pixel stretching and the second one is the gradient field UV distortion. So we will use the pixel stretching for this liquid flowing effect and then the gradient UV distortion for a 3D reflection effect. This video was inspired by a tutorial from Panic. They make really great touch designer tutorials. I also recommended them before. And the tutorial I'm basing mine on is called Liquid Image Displacement. You can find it in the description of this video. So this tutorial consists of 3 parts. The first one is setting up the feedback system. The second one is the pixel stretching for the liquid flow. The third one is implementing the gradient field. And in the fourth one, we'll sample a texture using this gradient field. I will start with an almost empty max patch. I have a jit.world object because we're working with textures, so this will be our rendering context. Here is a jit.p window to monitor what we're doing. And here I have an input video. So starting with the first part, setting up the feedback system, I will use a jit.gl.pix codebox. Then I need 2 textures, dimension full HD, and let's also say that this is float 32. And that we don't want to change it. So I need this one twice. So here we can say that the first input is called picture in. The second input is called feedback in. And then let's say for now that the output is just the first input. Then I can plug this in here, this in here. The input goes in here. I will activate loop. And then we can plug the output in here. Start the jit.world, start the video, and now we can see the beautiful input video. Oh, I also forgot to connect this here, so we have a feedback going. But as we're just outputting the first input, no feedback loop is happening at the moment. So coming to the second part, the pixel stretching. So how are we going to do this? So I explained this in a previous video, but essentially I'm taking an input texture, and from this input texture we'll only use the first row of pixels and then drag them down over the whole texture. So I will show you what that means now. So as an input I will use a jit.gl.pix. So with this object we can have different kinds of noise functions. I will use just a noise simplex. And this object needs a texture as an input. So we can use a jit.bang to bang this texture continuously. And now we can see what that looks like. We can also change the zoom. Let's say something, I don't know, like 7. Okay. And to animate this, we can use the time attribute, and I will use a time. Let's set the speed to, I don't know, 0.5. So what this does is it puts out a growing number, and depending on the speed, it grows faster or slower. And with this we can animate, the input here. But I don't want to have the whole thing, I just want to have the first row of pixels and then drag them down over the whole thing. So to do this, first we need to how will I start with the animation? No, I will start with creating an edge, so just the first row of pixels. So this is okay. To do this, I need the size of 1 pixel. So the size of 1 pixel is just 1 divided by the dimension of the whole texture. Then I can say that the edge is the normalized coordinates from the y position. So let's quickly look at what this means. So here we can see that we have values ranging from 0 to 1 on the y-axis. And now we can say that if this is bigger than our pixel size, okay, you can see nothing is happening, or at least not what I wanted, because now we are displaying all of the channels, but let's just take the X component of this. And now you can see that everything is white except for one black edge, which actually we can't see because it's just the size of 1 pixel. But if I'm multiplying this by 100, we can see we have here the size of 100 pixels or the size of 1000 pixels. But for our use case, we only want the size of 1 pixel, so I can delete everything else here. So even if we don't see it because it's so small, you can trust me, it's there. Then next we need to create a movement vector because we want to drag this down over the whole over the size of the whole texture. So the movement vector is a 2D vector with 0 on the x-axis because we don't want to move it on the x-axis, we only want to move it on the y-axis, and 1 on the y-axis. And then we can also say, okay, we multiply this by 1 pixel, so each frame we will move the distance of 1 pixel. But I will now also create a parameter called speed. I don't know, let's set this to 3 at the moment. Then we can multiply this by speed. And now we're not just moving 1 pixel per frame, but 3 pixels. I will also create a dummy inlet just to make it a bit cleaner. And then I can create a message out here that can then access this speed parameter. Oh, no. Here we are. Okay. Still nothing happening, so we can now implement the sampling. So I guess I can take this from here and put it here and say that this is the feedback input sampled at the normalized coordinates minus our movement vector. So what this essentially means is that with every loop, with every iteration, we'll move this amount in our sampling function, so the whole thing is going to get dragged down. I will also set a bound mode here. Let's use clamp. And then we need a way to mix between what's coming in here as kind of the new texture and what gets sampled in the feedback loop. So we can say that, I can put it right here, that our output, no, that's not what I wanted. We can say that the output is a mixture of our picture that's coming in and of our feedback that's coming in, and we're using the edge to control this. So how does this work? If the edge is 1, then we're taking the feedback, and if the edge is 0, then we're taking the picture that's coming in. And as you can see, it's 1 for almost the whole texture, and it's 0 just for one pixel. So what's going to happen is that for the whole texture, we're dragging down whatever is coming in at this 0 point. And if I didn't make any mistake, this should theoretically be working. Yeah, now you can see. We can duplicate this to see what is actually coming in. And now you can see we're just dragging the first pixel down. So this is already looking interesting. But as you can see, all of these, what would I even call them? All of these holes, all of these structures are moving in the same or at the same speed. But if we use the input that we're getting here and multiplying it by our movement vector, different, let's just call it pick in, different regions will move at different speeds. So you can see now we have this kind of liquid flowing effect. Because the movement isn't the same for every pixel, it depends on what kind of texture is underneath. So that's it for the second part, for the liquid flow. I will tidy this up a bit. Maybe do something like this so we have enough space. Yeah, as you can see, if we change the speed of the flow is changing. Okay, so coming to the next part, which is the gradient field. So to get the gradient field, I will again create a codebox here. Put this one in. And for the gradient field, I want to take, for each pixel, I want to take the neighbor to the left, to the right, to the bottom, and to the top, and then compute the differences to see, to detect more or less the edges. So for each pair up down and left, right, we'll see, okay, how much difference is between two consecutive pixels. So to get the neighbors, I again need this pixel variable we all also used up there. And then I can say, okay, the pixel to the left equals, no, let's use nearest this time. So the difference between sample and nearest is that this will interpolate and this will just use the pixel that is nearest to the input coordinates that we gave it. So we can say we're sampling input 1 at normalized coordinates plus an offset, and this offset for the left is -1 on the x-axis, 0 on the y-axis. Then we can multiply this by our pixels, so it has the size of 1 pixel, and we can also use bound mode clamp, so it doesn't wrap around, it doesn't mirror at the edges. So then I can copy this 3 times and say, okay, for our neighbor at the right, this needs to be a 1. For our neighbor above, this needs to be 0 in the x direction and 1 in the y direction. And for our neighbor down, this also needs to be 0 in the x direction, but -1 in the y direction. So now that we have the neighbors, we can compute the differences between them. So for the differences on the x-axis, this would be left minus right. Now that's how you spell it. And for the y direction, would be up minus down. And then I can output this. So output 1 equals a vector that consists of x and y. And so we get the difference for both directions. Now to see what this looks like. We don't see much at all. We have to scale this, let's say times 100. Now we can see where there's a difference in the x direction. This texture is red, and when there is a difference in the y direction, this texture is green. So, okay, got an error, but I think it's an old one. Yes, okay. So I will delete this vector. Also clean this a bit here. And what also might be interesting is having a way to reset this whole thing. So to do this, we can use the message clear and send it to the feedback texture. But as you can see, we're getting this pattern when we're resetting. So we have to say at default image black. So this means that when we're resetting, the picture will be black. Great. Coming to the fourth part, where we're actually using this to sample the input texture. Slowly running out of space, so I will again use a jit.gl.pix codebox. Put this one here. Output is coming from this one now. I don't know, let's do something like this. So I will again use a texture as an input here. So what do we actually need here? We need the picture that is coming in. Let's say this is input 1. Then we need the distortion that is coming in. Let's call this distortion in. This is input 2. And then we need to sample this. So we'll sample the input at normalized coordinates and then add in the distortion to those coordinates. So we can say sample picture in at our normalized coordinates plus the distortion that's coming in. I will also use the bound mode clamp here. But I'm running out of space. Okay, I can just do something like this. Okay, now we can see our input video. And then I can connect this distortion here. And then we can see the liquid flowing. It would also be nice to be able to control this. So let's say that we're using a new parameter called amount, and then we can multiply this by the amount to change the amount of the effect. So again, with the parameter, I can control this with a message. And if this is 0, no effect. If this is 7, there's a lot of melting going on. And again, we can change the speed here. And we can restart it when we're clicking on clear. So restarting, now you can see it's flowing down. Yeah, so this is essentially the main thing. What we also could do is change the color of the liquid. To do this, we can do something like, I'm going to copy this, put it here, say out1 is, let's just say it's 1 for now. And let's call this one picture out. And then we can say that for our output, okay, let's first define a color. So let's use some kind of blue. Oh, that's not what I wanted. So I don't know, 0.2 on the red, 0.3 on the green, 1 on the blue channel. So now we have our liquid color. And then we can do something like mixing the original out picture with the out picture multiplied by the color, so it's the colored version. And then we can use the amount to mix this. But the problem is that the amount can go over 1, so we can do something like clipping the amount and say, okay, this can only be between 0 and 1, and maybe also multiply this by some factor. But I don't quite like this. This is not what I was going for, because now we're multiplying the whole thing. So maybe we should also use the distortion that's coming in. To multiply the amount of color. Okay, still not what I wanted. Maybe this one needs to be picture in. Okay, let's debug this real quick. Let's just see, okay. Is the color I want? Yes. What does it look like if I'm multiplying what's coming in by this color? Okay, what does it look like if I'm multiplying what's coming out by this color? Okay, so maybe this should be pick out. And maybe... I see now what the problem is. Because if I'm just using the distortion that's coming in, I'm essentially using this signal and nothing is happening. So we need a third input. Let's call it color mix. Let's say this is input 3. And then we can use what's coming out here directly. And then I can say that I'm not using the distortion that's coming in, but the color mix that's coming in. So now, if we start it over, we can see that we have this blue tint, this blue gooey thing. Okay, this was essentially what I wanted to show you in this tutorial. I hope you found this useful. Thanks for watching.